So before I start to begin the commencement of this talk, I'm going to tell you a couple things. You're basically seeing a beta version of a all-day tutorial that has been pared down into 50 minutes and therefore will probably take about 70 or 80 minutes to deliver. Now, it comes in 3 parts, and probably the second part will end around quitting time. And if anyone wants to leave then, I am totally okay with that. But I'm just going to keep going. I think everything I'm talking about in this talk is either interesting or important or funny, or I just thought it was a really fun slide. So I didn't want to cut anything out, and I made several attempts to sit down and do a careful timing run and figure out how long it was going to take and what I could cut out. But unfortunately, what I found was every time I started to do that, I deleted one slide, which made me think of a new topic to cover, and I added about 10 more slides. So I'm going to go fast, but it doesn't matter because we got a long way to go. So today I'm going to be talking about handling strings and text and Unicode in Perl, and the talk is called A Million Billion Squiggly Characters. Can anyone name any of these characters other than the 1/10th? M. No, that is not. So it looks a lot like Latin capital letter M, but it is not. That is Roman numeral 1000. We'll come back to this. Okay, Perl. What even is it, right? Okay, so Perl, it's a language, it's a programming language, and what is it famous for? It's famous for dealing with strings. And we're going to be talking about strings, but it's important to think first about what strings are. And what are strings in a programming language? When we talk about programming, they are something we think about a lot, and there's something that we don't tie to strings as often as we should. Strings are just a data structure. Strings are one of many different data structures in programming. So here's a string. Take a minute to look at it. It's a sequence of bytes. And I bet you can guess what kind of string we might call this. It's a C string. Yes, that is exactly what it says in my notes, a C string. How about this one? That's a Pascal string, right? We start with our 4, and then we get our 4 characters. How about this one? I'll give you a hint, it's not a string. It's a rope. Very good. Yeah, that's a rope. This is what strings look like in Perl. I've slimmed it down a lot. We've got a thing, and it points to a whole bunch of bytes. Okay? Keep going. So strings are a bunch of numbers. That's what we had here. It's a bunch of numbers. Computers work with numbers, and then we map the numbers to other semantics. Okay? We map these numbers to semantics, and that's something you need to keep in mind when you're working with strings in Perl. Or anything else. Back to our C string. Can anyone tell me what that C string says? I'll give you a couple seconds here. I know there's a lot of ASCII heads. Right? It's actually an EBCDIC string. I'm going to be pulling this crap the whole time. And the problem is, right, we have numbers that we map to meaning. And when we map between two things, the mapping itself is a thing you have to think about. So yeah, we usually assume that we are using ASCII, especially when we're down here in the low 7 bits of our character space. Up in the higher bytes, though, we have all kinds of stuff. So here is a string. It's a non-terminated, non-prefix string. I don't know what's going on. And it might mean these characters. This is one of my favorite character encodings, code page 437. It's what all your old DOS games that were text-based used for drawing cool-looking screens. Latin 1, which everyone is probably familiar with. This one, anybody guess? Latin 2. Latin 3. How about this one? Shift JIS. And take us back to EBCDIC. All right. So we have all these different ways of interpreting the numbers. The numbers are just numbers, and the meaning comes from something external. Okay. So here are characters, glyphs, things we might think about as being meaning. These are things that a number could mean. They have names. Our collection of all the characters and all the concepts that we want to encode, we're going to call that our character repertoire. So once you write down all the characters you can use, you have your character repertoire. In ASCII, we had 127 roughly characters. In Unicode, we're going to have a couple more. These are concepts. And then we give each concept a number, right? So every concept gets a number. How much color distinction do you get between those, by the way? None? Okay, they're different. I don't think it should matter too much. But we'll see. This talk has a color scheme. So these are numbers for those characters, for those concepts. We call those the coded character set. We take all the concepts, we give each one a number, that is our char set. These are just numbers. And then when we put them into a file, files don't store numbers per se, files are streams of bytes. And these are our bytes. Lots of the time we're used to things, this is called our encoding of the string. We're really often used to thinking about the coded character set and the encoded bytes as being the same. Because when you talk American, they are, right? They're all going to be the same characters. And even when we start to broaden our horizons and we go into the first bunch of Unicode characters, those are Latin 1, and you can write those out as bytes in a file if you're doing Latin 1, and it all makes sense. And if you're working with strings that are Unicode strings in Perl, you start to think that it all makes sense because it looks like the same numbers. But if we encode things differently, we realize that the coded character set and the encoding are quite distinct. You might write a file out, and this is what you write. I know those numbers are small, but can anybody guess what this encoding is called? UTF-7, yes. Very close, those of you who said 8. And even these idea of our concepts, the concepts are also tricky. So this is a character we've probably all seen. Unicode calls that part of the character repertoire Latin small letter n with tilde, usually. Sometimes instead what we have is an n and a tilde. And those are two separate characters that we display together. Now, when we're back in Latin 1 land and thinking about, I support the whole world, the US and Europe, it can be really easy to not worry about combining characters because you don't need to deal with a combined character. You just deal with the combined character and not the decomposed one. And everything you get, you can fix as you go. But there are lots of places where that's not the case. So here is the symbol Gog. And this character is actually those three characters. So I've got three characters, and if I start deleting the space, I'm not going to try and pronounce their names. If you take those and you delete that first space, keeping the characters apart, you get that. And then you delete the next space. This is a composed character. If you want to deal with these languages, you really need to know about the idea of characters coming together and forming one big character. So, like this thing takes us even further from the model of concepts to numbers to bytes on disk. We started with strings. Okay, so we might have a string, and a string is a sequence of things, right? And let's call a string a sequence. We could have, or a list. We could have a list of bytes, and that would be fine. That's like what's in a file is a list of bytes. We might have a list of code points. Those are the numbers for our concepts, or a list of characters themselves, or those things that we got that combined the n with the combining mark, or those many Hangul that came together to form the big one. We call those grapheme clusters. So we can have a list of any of these things. And what's the type, right? So the first one is a list of bytes, or a list of code points or characters. These are basically the same, because we have a one-to-one mapping between code points and the characters. Or a list of grapheme clusters. And the thing you need to know when you are programming, super important, is what type of data you have. If you don't know what type of data you have, you don't know what kind of operations you can perform on it. It's fundamental, right? It's why you end up with all these funny JavaScript jokes about people who use the wrong operation and they say x plus 1 plus 2, and one of them is the wrong thing, and they end up with undefined is not a function, right? You need to know the types of your data. So this is really simple. A list of bytes is a buff, a list of characters is a uni, and a list of grapheme clusters is a stir. Those are the types you get in Perl, and you need to know them. The main problem with that is that's Perl 6. So how does this work in Perl 5? Let's review how types work in Perl 5. What type of variable do I have here? Scalar, right? And how about now? What kind of variable is that? Okay, so we've gone from one character scalar, multi-character string, that's fine, they're scalars. But let's go to a number. What kind of variable is that? Scalar. Okay, how about this floaty one? Okay, so we go back here, and what does Perl do for us? You have a list of bytes, you put that in a scalar. A list of code points goes into a scalar, and a list of grapheme clusters that kind of go into a scalar. We'll come back to them much later. Did you really think that a language that couldn't tell you if something was a number or a string was going to tell you what kind of string it was? Lol. So when you are working with a string of characters, we have text. A string of characters is text, and a string of bytes is a byte string. And when you move from one to the other, you are encoding and decoding. You need to encode and decode the right time and the right way, and only once. If you have a string of characters and you encode it, you get out bytes. You have hello, you encode it as UTF-8, you get some bytes. If you encode it a different way, you get a different set of bytes. And if you have a different string and a different encoding, these are just operations you can perform. Encoding a character string is a very simple transformative operation. Okay. The other way is really simple. We can take the bytes and we decode them with the same encoding, and you get the string back. Everybody with me? This part's easy, I hope. We have a map between strings and types of bytes. It's called encoding and decoding. If you have a character string and you encode it, you get bytes. But then you don't know that you have bytes. You get this string from somewhere else. You don't know whether it was bytes or whether it was characters, because Perl can't tell you. And you guess, and you're wrong. So you encode it again. Now you get these bytes. And somewhere else in your program, you encode them again. Right? And pretty soon, all that's left in your program is a bunch of crap. If you don't know what kind of data you have, you can't perform the right operations. It's a little better when you're decoding. You have some bytes, and you decode those. You have some code points, and that is the string crep. But then you decode it. So now instead of encoding too much, we're decoding too much. And you get this thing. So that little character, by the way, you've seen this, the square character with the question mark drawn on it? That's called the replacement character. And it's what you're supposed to do if something decodes to something invalid that doesn't exist. Keynote, which is my slide software, won't even let me put it in my slides. It's like, you can't use the replacement character. It would make us look like we made a mistake. So that's what it would look like. Then we take that string, and we're going to decode that. Now, something unusual going on. Again, I know this is small. What's going on in that crazy byte string? FFFD is not one byte. And so we tell Perl to decode that, and we throw an exception. You can't decode something that isn't a byte. Decoding is an operation you perform on bytes. So I hope I've made the point that you really, really, really need to know the type of your data. And there's a lot of crazy ideas about how you get it, and I want to talk to you about how you actually know what kind of data you have. You've got some subroutine, and it gets past a scalar. And we'll start by assuming it's a string, and you're going to operate on it like a string. But what kind of string, right? Is it a byte string or a text string? So this is our slide about how Perl strings look internally in the Perl interpreter. I've left off some bits, but this is enough for now. We've got SVUPV. Now, for those of you who think that sounds crazy, I can tell you this is actually a recent renaming. This used to be called the PVX, so it made more sense before. So we've got this thing, and this is just an array of chars, right? Which means they're values between 0 and 255. And cur tells us how long is the Perl string that this represents. So for example, that's 4, and that means only the first, it's a 4-character string. So if you look at $stir, you'd see those 4 things. Everything else is It's just left over. It's to be memory efficient. And len tells us the length of the whole buffer. So if we resize that buffer, we don't need to allocate more memory unless we exceed len. Okay, any questions? Okay, so that is what a string looks like in Perl, and it's very easy to see how we map between bytes and elements in an array. The problem is, we'll go back to this guy. This is character AC01, and as you may recall from the way bytes work, you can't fit OXAC01 in one byte. By the way, you're going to see this U plus over and over. It means this position in the Unicode encoded character set. We can't fit AC01 into a char. So what are we going to do? Well, a string also has a bunch of flags. It's a bit field, and you can turn these flags off and on. And one of them indicates it's a wide string. This string can contain wide character, data that fits in more than a char only. If that flag is off, it looks like we saw before. Out of the current length of the string in memory, there's a one-to-one correspondence between the elements you see in Perl and the chars that we stored in C. If we turn the wide flag on, then we're using a variable length encoding. And the contents of the SVUPV, you can't even make a funny pronouncement of it. SVUPV, it's not, you got nothing. Those bytes are representative of something else. And we've got a decoding step here. We're taking some bytes and transforming them into something else. The problem is, we're using an encoding here that looks a lot like UTF-8, which is the way that you often encode Unicode characters into bytes for interchange with the rest of the world. But it's not UTF-8. It's just very, very similar. And some joker went ahead and they called that the UTF-8 flag. And then you say, great, if that's on, I know that I've got something, I UTF-8 decode it, and now I have text. Great, so if this is on, I know exactly what's going on with this string. Well, so here's two strings in Perl. One of them, they're exactly the same SVUPV. One of them has the UTF-8 flag, and one does not. And so the elements you find in the string are these elements. Which one of these is a character string? I'll let you take a minute to think about it.
I've learned not to answer your question.
Mission accomplished.
The advice of my attorney, I must respectfully.
Okay, so that's right, you can't tell. You can't tell which one of these is actually the character string, and it turns out the situation is this. This is the content of the SVUPV. So this is what you see if the wide flag is off. Is that the character string? If the wide flag was on, this is what you would see in the scalar. This is that passed through Perl's internal encoding mechanism. If you take that string and you pass it through the UTF-8 algorithm to decode it, you get this, which is the actual string. This is what we wanted to deal with. It just turns out that we had a bunch of UTF-8 bytes in a string that happened to be marked wide. The criteria for when a string gets marked wide is whenever something feels like marking it wide. It doesn't tell you anything unless you are writing C. And if you are writing C, this talk is not the right talk. We are talking about dealing with this stuff in Perl. That string, by the way, is this. So many, many people have gone through this with this idea that the UTF-8 flag tells you whether you have text or string, but it has tricked you. You need to throw that away. You can find out whether the flag is on by saying, hey, is this string UTF-8? It might tell you whether the flag is on or whether it's valid UTF-8 code points, but that doesn't tell you whether it's actually text or not. This is the source, by the way, of what was called the Unicode bug, which is this idea that different parts of Perl would act differently. The operators would act differently on a string that had the wide flag turned on or off, even though the code points were the same. It's a crazy bug and has largely been eliminated by the work of Carl Williamson, who's one of the Unicode people working on Perl. But it's still there, and reading about it will give you some ideas of what's going on with your own bugs with Unicode handling. The other thing to know about is bytes.pm. Bytes.pm is a lexical pragma that says, in this scope, just ignore the wide flag. Stop decoding it into Perl's space. Just deal with the bytes in the SVU-PV. When is this going to be useful? Yeah, that's right. It's not. Don't do it. Don't do it. It's useful in very, very limited circumstances, like debugging really crazy bugs. This is a last resort. This is not your way to speedily bypass UTF-8 encoding things. Okay, so we know the wide flag didn't help, but we still need to answer this question. There's a trick a lot of people don't know, and I really like this trick. I learned about it pretty late in my career Perling. If we have this, we have a string, and we take a reference to it. What does this program, just this program run? What does it do? It prints scalar? No, it says you're not using V510. I don't know what say is. Sorry. But yeah, if we fix that, yes, we get scalar. That's a scalar reference. How about this one? Right, it's not a V thing is not an object, to let you know. So what's that going to print? Scalar, right, because we don't know the difference between scalars and numbers, but it actually turns out it says V-string. What? There's a bunch of these. There's a bunch of these places where a thing that looks like a normal value, that is nothing special, it is just a scalar, gives you a different value under ref. There's you can see glob ref, and you can see L value. It's great. Or ref. But let's go to a program where we have a program, and it's going to have one thing that returns text, where I guarantee you it is properly returning text, and another one that returns bytes. Definitely returning bytes. And we say the refs of those. What does this program give us? We forgot 510 again. But yes, I heard scalar. It gives us scalar in both cases. This is a great trick for many things, but not this. Okay, so we can't use the data type. We can't check, what kind of sigil do I have? What kind of ref is it? We can't do the in-referencing it and dereferencing it and checking the ref type trick. We can't look at its flags. Some people will then look at, does it have any elements that are over 255? Well, that just tells you whether it's a wide string. I can put any kind of sequence of numbers in there. That doesn't mean that they are semantically a string. And beyond that, it doesn't matter. Because you can have text strings that all have code points under 256. So there's only one way to solve this problem. Now, this is going to be a hard thing to accept, but does anybody know what the answer is?
Give up.
You just have to know. You have to audit your whole program. You got to know every subroutine that you wrote, what it expects and what it returns. And every subroutine you didn't write, you have to know. It sucks. There's nothing else to say about it. This is fixed in a very few other languages, but Perl 5 is not one of them. So here's how you accomplish this vigilance. When you get input to your program, that input is in bytes, because that's how input works. Right? Input comes over a byte stream. So that is when you decode it. As soon as you are getting input, if it is something encoded, you decode it. And now you know anything you're dealing with is text. Inside of your program, you make sure that all your strings are text, like string literals, strings that are being passed around between things, those are text. They're characters, not bytes. Unless they should be byte strings. If you're passing the contents of a JPEG, don't decode it. It's not going to end well. And Lord love you, consider using your variable names to tell you what's in a string, like you're writing VB or something. You can often avoid doing this if you know all your code has the right expectations. But if you're dealing with something in both ways inside of a subroutine, it's basically the only way you're going to solve this problem. When you're dealing with code you didn't write, find out what the libraries expect. Do they want you to pass them bytes? Do they want you to pass them strings? And if it's not documented, read the code, figure it out, and send them patches. So important. For everyone else using this library who doesn't know what their code is expected to do, you are going to be helping them enormously. And what you will often find is the person who wrote the library has not really thought about it. You have to work out what it actually is from their tests, from the way that it's coded, and then you can tell them what it needs to be to keep working. Really, really important. then once your program is putting output out, you can only send bytes out of your program. That's the way output works. So make sure you've encoded all the strings before you output them as late as possible just for the output. But don't encode them more than once, because then you get crazy crap in your code and your output streams. So the only way to make your code work is to very painstakingly audit your code or hope for the best. Hope for the best actually works more than I'd want to say. It's okay. But if you want it to really work reliably, and if you want to be able to reason about your code and debug your problems, I try to avoid thinking when I do programming, because I'm better at programming than at thinking. But sometimes you have to. Like, sometimes you have to think about your problems. And if you want to be able to reason about your problems, you need to know the types of all your data. Okay. So this concludes talking about the problem in the abstract. It sounds pretty bad. I'm going to talk about some specifics now and what you can do in your Perl program, how you accomplish these steps. Hopefully this will be short and painless. Input is the big thing. You need to decode all your input, and your input comes from about these 4 places: arguments to your program, the files that you read from in your program, your standard input. Standard error apparently is now an input to your program. I didn't know that until just now. And strings inside of your program that are getting passed around. Not just literals, but also string variables that come from places other than your own code. So how do we deal with these? So here's a simple program. It takes a string from its arguments and it tells you how long it is. But it's getting a byte string. argv contains bytes. And if it's something encoded in UTF-8, you're going to get the wrong number of bytes back. So what are we going to do? There's a pretty simple solution to that one. And you put on your shebang line, when you run the program, -CA. -C says, I want to change how you're going to handle input and output encodings from this program. And A says, decode all the incoming argvs with UTF-8. And that's pretty good. It's going to work. You can put it in a program, and then you run the program, and we've got our funny little UTF-8 character, and it says that's 8 characters. And that's correct, right? EAT, PI, E circumflex, and the dot in the space, 8 characters. It worked. But then we've made some change to our program, and we're going to run it like this. Perl-I in our program. And we get this weird error. It says, it's too late for -CA. What's happening is, if your program is not run by the kernel using the shebang line, then Perl starts up. It looks at the shebang line, and it says, oh, I should turn on the switches in the shebang line. This is why you can do stuff like put -big T in your Perl program. The problem is, by the time it's gotten to that part of your program, it's already initialized the arguments. It's already initialized all the file input outputs. So -C is okay if you only ever run the program from the prompt. I always run programs like this, all the time, constantly. So I never use -CA. There's 2 ways to solve this. One is when you run the program, say perl-ilib-CA. That means you're going to run all your programs twice, right? Once to find out what option you should have used, and then once again with the option. Or you always use the same option, but good luck with having that work out. Or you can set an environment variable called Perl Unicode, which acts like all of your programs have had that -C switch turned on. The problem with that one is that now it's all your Perl programs act like you have that switch on, even the ones that wanted different switches, or the ones that were written without these switches that are going to do their own decoding. So I never use that one. And if you are running one program, it's a server, you've got it running in an isolated environment, you know it's the only thing, then you might be okay. But I don't like to think about things like that. So these are okay solutions, but they're not the one I'm going to tell you to do. What I'm going to tell you to do is to drop that and just decode your argv. I just say, I know 99% of the time the arguments to my program are all strings. Sometimes they're not, and in those cases I don't decode. You can build this into your getopt. I thought about showing this built into a getopt, and then I imagined each individual person telling me they liked a different getopt. So I didn't do it. And here I'm introducing a library called encode. Encode is part of the standard Perl library, and it's for doing encoding. Or, as you see here, decoding. I'll talk about it more in just a little bit, like now. When you decode, you call encode decode. You can import that. First, you tell it the encoding you want to use. Here, you saw me using UTF-8, which is what you use most of the time for most data these days. But you can use anything. You can use UTF-16, Latin 7, whatever you want. And you pass it the string, and you pass it a check. Check, by default, is FB default, fallback default. And that takes anything it can't decode, and it turns it into a replacement character. That's often the right behavior. The other thing that can be the right behavior is to use FB croak, which says if you encounter anything that can't be decoded, throw an exception. You should be using encode, decode all the time. You're going to use these things so much that you're going to get sick of them. But they're better than bugs. If you decode a string like this, you start with bytes, you get text, and here's what you get out. Another way to write that is decode UTF-8. Now you'll see two differences here. One is I lowercased it. That doesn't matter. That's just convention. So if people tell you that these things differ in case matter, that the difference in these cases matter, they're wrong. The other thing is I removed that hyphen. That might be the most important hyphen in Perl. It says don't use the UTF-8 algorithm for decoding. Instead, use the algorithm that Perl uses internally for the SVU PV when the wide flag is on. It's a lot faster, but it's not always right. How often is it wrong? Pretty rarely. So that doesn't mean use it. That means when you have to debug it, you're going to be much more confused than you might have been otherwise. So that one's no good. You can also use UTF-8 decode. So from the built-in, that's a built-in. You don't have to use UTF-8 to get it. But it does the same thing. Oops. It uses that UTF-8 with no dash. Encode also gives you a library to make this a little easier. So instead of having to say decode, paren, double quote, UTF-8, and so on, you can just get decode UTF-8. My program's all going to be UTF-8. Unfortunately, because you can't put hyphens into Perl identifiers, this had to use the lax crappy version. And so I don't know why it does that. But don't use that either. Use that first form, at least until we convince somebody to fix this other one to use real UTF-8. So that fixes your argv handling. Yeah, Chad.
That covered the code, but on encode, would using the one without the dash be bad? Is that ever going to run into the way it decodes?
I'm not sure, but I might have said so in my slides, so we'll find out when I get there. The question was, is there a problem using encode UTF-8, encode underscore UTF-8? And I'm not sure, but I would avoid it because I'm not sure. Actually, what I suggest doing is find out the answer and then act appropriately. Yeah.
The reason I brought it up is because there's a bug where, I can't remember what it is, but if you, exactly what it is, but where if you use the other UTF-8 with threads or something, it'll crash on half the computers you run it on.
Awesome. Okay, so there's a thread bug that sometimes causes the other one to crash. We're going to get that fixed somehow. Okay. Okay, so we've talked about your arguments. Now let's talk about files. So we've got a subroutine here. It takes a file handle. It iterates through the lines of the file, and anytime it sees something with a Hangul character, and don't worry, we'll explain what's going on in that regular expression later. Anytime it sees one of these, it says it saw one of these. What is a file? When we read from a file, what do we read? Bytes. Yeah, right. It's not a trick question this time. We're reading bytes. Files are just lists of bytes in Unix, and many other operating systems on which Perl runs. So if we read this, we're never going to see a Hangul character because they don't live down in the space of bytes. We have to decode the stuff we get. Now, you could say, read the line and then decode it, but that's going to be a problem for reasons I won't get into right now. Instead, there's a thing in Perl where you can apply what is called a discipline or a layer to your file handles. So here, we're going to change the bin mode of the file handle and say, this thing uses an encoding layer. When you read from it, it is UTF-8. Decode the stuff you're reading and give me back characters. So when you read from a file, like in C, you always get bytes. In Perl, your file handle might give you bytes if it's raw, or it might give you text if it's got an input layer on it. Okay? And again, you can use anything from encode supported on that encoding handle. You can say that this is a UTF-7 file. You can say it's KOI-8 Ukrainian. Just don't use UTF-8. If we open the file ourselves, we can put it into the opening call. So when you open a file, you can decide whether or not the file is going to be encoded content that you decode or whether it's raw content. And then you read from it. Don't do that. You can also say this. Use open. The open pragma says anything I open in this scope has this layer attached to it. Now, there's something really important to think about here. It's a lexical pragma, right? And a lexical pragma only has effect in that scope, which is great. And you often think, so I can just turn this on all my programs and it works. The problem is file handles are things, and you pass them around between different parts of your program, and they go into other scopes, into other lexical compilation units. So you can say use open here, and it's safe because this file handle never leaves here. But if you return to file handle, or if you accept a file handle from somewhere else, that use open call is not necessarily helping. The only thing you can do is know through careful auditing what kind of file handles are expected. So now, not only do you need to know whether your strings are text or bytes, you need to know whether your file handles are string file handles or byte file handles. Sorry, that's all you get. So next up, standard in, and just standard in. When you do something like this, you are actually saying that, generally. When you print something, you're printing it to a file handle, and the file handle is a thing you can find. So if you want to be able to say stuff going out here gets encoded, what do we use to tell a file handle to encode stuff on the way out? Bin mode, right? So you can do that. You can say, I want to say stuff that gets printed to stood out gets encoded. You can also use open here and say standard. When you say use open std, it means apply these modes to the standard input and output file handles. Now there's a problem with both of these. The problem is you're affecting global variables. Now earlier with the file handle that we opened and kept in one subroutine, we had to worry whether it was being passed around, and if we could be certain we weren't going to pass it to anyone else, or that we weren't taking a file handle from some other part of the program, then we knew it was safe, because you could audit that easily. Here, that stood out. You know, that's everywhere. Anybody could be talking about that without you knowing. So you might be okay with that. Really, when you write a program, you like to imagine you're the only person who is writing to its standard output. But you might not be. You might have other libraries that write to it. And in a case like that, there's a little goofy thing you will have to do. Who here has seen this open mode before? Okay, a couple people. What we're doing there is duplicating the file handle. So we end up with $out containing a second file handle to the standard output stream. And then we can put bin mode on both of those, and they're totally distinct. And you can duplicate the file handle as many times as you need, lexically, and be able to encode only the bits that you're writing. It does mean you need to use that one. Now really, to be safe here, and not just for the joke, I would not be bin moding the global. That was the whole point. But you're only going to really use the locally duplicated one that has the encoding layers you know about. Then you can say things to these file handles that are encoded differently, say exactly the same input, and from one you get here our Rye cat face, and another you get the UTF-7 encoded thing. Okay? Great. If you run this program with no encoding on your output layer, this is not going to work in C because you're trying to write an int to something that only takes chars. Perl, though, will happily try and shove it through that output stream, because that's what Perl does. What is this going to print?
It's gonna die.
Yeah, well done. Yeah, so I think that joke might be done. I'm not sure. It's at least not on this slide, but good, well predicted. The other answer I heard was wide character and print. Actually, we get wide character and say. You were very close. And then we see the UTF-8 here. What it's telling you is you tried to print something that doesn't fit over print, over the output stream that I'm using. So instead of throwing an exception, instead of guessing at an encoding layer to use, I just sent the contents of the SVU-PV. So often it's going to be fine because that's very similar to UTF-8, but it might not be. And there are cases where sending the raw contents of an SVU-PV that is valid inside of Perl will trigger security bugs in other programs. Seriously, set up your encodings. So that's getting this, and I know I've jumped into output, sorry. And now back to strings that are inside of our program. Okay, so we get some text out of a string, and I'm going to promise you getString returns characters. And then we're going to send it to something that is doing output. So we need to encode. Nothing special, we just call encode. You saw earlier how you decode, this is how you encode. If you get something that has bytes, and you're going to pass it to something that expects text, you decode it. It's fine. But what you need to know is whether something is text or bytes. All of your program subroutines have been documented. You've sent patches to all the libraries you use. They're all documented. But what about here? Does that string contain bytes, or does it contain text? This is a raw Perl program. Any guesses? This is the whole program. Someone says bytes? Okay. And who thinks it's bytes? Okay, about 3 or 4 people. Who thinks it's text? About 3 or 4 people. This is some very wise people in this audience. Well, now I think the answer is it is neither text nor bytes because we're not doing anything with it. It's just data. Yeah, that's right. It's a superposition. We don't know. We don't know. We don't know whether this is text or bytes because we haven't assigned any semantics to it. This is about semantics and what the data means. Now, let's say the file is encoded in Latin 1. These are going to be the contents of the source code. So that's a bunch of code points, or bytes. Here they're the same thing. If we run a match against it for one of these non-ASCII characters, it works. If we say, what's the length of the string? We get 9. And if we print it to a file handle, we need to encode it UTF-8 to get UTF-8. So that's behaving just like we would expect a string to behave if it was text. If our file was encoded UTF-8, this is what's in the source code, and therefore in the string. If we try matching against one of these high characters, it doesn't work. The length of the string is 11, which is not what we expect. And if you try printing this to a file, you don't need to encode to get valid UTF-8, right? So the solution here is just start writing all of our Perl in Latin 1, right? That's the solution. So what's going on, right? Is it the case? Why is our correctly encoded string becoming the wrong thing? And does that mean we just have to avoid using high stuff? Well, you can write a program that looks like this. Okay? There's no ambiguity here. What if this file was encoded Latin 1? Well, it's not, okay? There's no way this file is encoded Latin 1. We can't put that guy's name in Latin 1. So it's UTF-8, okay? This kills our plan for writing all of our code in Latin 1. It's too bad. If this is our program, we can't match Unicode-y stuff because what we have is not Unicode text but garbage. The length of that 5-character string is 13. It's no good. And we can print this out, and it acts like we've printed bytes out. Much earlier, someone mentioned use UTF-8. If you use UTF-8, you are asserting the content of my program is encoded in UTF-8. It's lexical. Everything from here down in my scope is encoded in UTF-8. So decode it, and the contents of the code points you get from a string will be the characters represented by the bytes on disk. Now, if this was the whole program, there still is a question like, well, is this bytes or is it text? But it's text because it can't be bytes. Now, if it's some other form of data that happens to have code points over 255, I guess that's possible, but then you are living in a strange, strange world where I have visited and you don't want to go. This would show up in our string like that. You can match properties against it. The length is 5, that's right, and you need to encode it again. So I always use UTF-8 in my source code, even if my program is ASCII, because later I can add non-ASCII to it and it just works. I also always save my files in UTF-8 because I am not a monster. Don't save your files. People, there's libraries that are written in UTF-16 LE. There's libraries encoded in all kinds of crazy things, and it all works fine until you do anything with it that seems reasonable and spat. Use UTF-8, please. Both kinds. UTF-8 PM and UTF-8 for saving your files. Now, that's fine for this program. And if you want to have bytes in your program, one option is to make it very clear this is binary data. I'm loading it in by giving you the byte values. And if you want to have a string that represents the bytes that are on disk without decoding them, which is something you maybe will do in tests but probably don't do anywhere else. Remember how I said UTF-8 is a lexical pragma? You can do this. And it tells the thing that is reading Perl's source, at that semicolon, from here on out till the end of the block, don't decode the source input. So your file is now in a state where parts of the file are supposed to be encoded and parts are not. You can use this. I do. But use it judiciously. Okay. Here, we're opening a file. We're still dealing with a string. We're not dealing with a file on disk, because what we've done, our third argument, is not a file name. You see that backslash? We're opening, this by the way is everyone else getting to go home. We have 80 more slides, great. So that backslash says, I'm going to open a file handle that addresses the contents of that scalar. So when you read from this string, you're reading positions in the scalar. But what does a file contain? Bytes, right. So if you try opening something that contains non-text, that contains text, that contains things that are not bytes, you have to put an encoding layer on it. And if you try reading from a character string with this mechanism, and it contains things that don't fit in bytes, Perl will just die. It's going to say, I don't know what game you're playing here, but you told me to read a string of bytes from a virtual file, and then you started giving me back stuff that doesn't fit in bytes. So you have to use your encoding discipline, even when you're using strings to emulate byte streams, which just makes sense. So that's all of the input discipline. Okay, output. Yeah, that's it, right? We're done. We've already covered it. You know how to tell files that they have an associated encoding, and you know how to encode strings that you're going to print to standard out, standard error. You're done, right? This is everything you need to know about your border security inside of Perl. Now, first of all, I feel pretty good that I hit intermission break at the end of talks, because people could get up and leave if you want. Any questions about this material so far? Yeah.
You said if you use open and open a file handle and then pass it to someone else, weird things can happen because the open is less than pragma.
Sorry.
Can you announce the silent auction ends at noon?
Yes, the silent auction will end at noon.
Yes, that's what I came in here to say. Check your items. The auction ends soon.
Killing me here, Yapsy. Okay, so go ahead, Matt.
You said the use open STD
Yep.
Is lexical only, and if you pass around file handles, weird things can happen. But if you open a file handle under that scope and then give it to someone else, won't it still have the correct layers applied to it? So when you do put it, you get the right data?
So so the question is, what kind of problem could you have if you've used use open to get layers onto a file handle and then you pass it around? Is that a good summary?
Yeah.
So imagine that you've said use open encoding UTF-8. So now when you open a file handle, it's got the UTF-8 encoding on it. And we're going to say this is for output. And then you pass it to something else, some other part of a program that expects a file handle that sends bytes. The layer is attached to the file handle, not to the scope. So when it prints to it, it's going to be trying to encode bytes, for example. And you can imagine many, many other permutations of that problem. Okay. Anybody else? Yeah, well,
So how do, I mean, everything, aside from, there are things other than Perl need to read files. How does cat, if you cat something that's UTF-8, how does it know?
if you cat something, okay, so the question is, what about cat and other programs? Cat's an easy one to talk about because cat just takes the bytes on disk and sends them to your terminal, and your terminal has an encoding. Yes, Sterling?
Can I interrupt real quick? If anybody here wants to do some sniping on the silent,
Yeah, it's already been announced.
like 5 minutes,
We got it.
so if you want to step out,
It was already announced.
okay, good.
Thank you.
Sorry.
Bar the doors.
Yeah, bar the doors. He didn't even bar the doors. So cat just sends stuff to your terminal. Your terminal has an encoding. So when you've connected to your shell, to your remote shell or your local shell, your terminal program knows how to take the bytes from the terminal and encode them. Other programs like grep, right? If you're going to grep for something, most Unix programs will respect environment variables defined by POSIX that tell them the encoding for your current your environment. These environment variables include, but are not limited to, lc_all and lang. And so if you use grep and you're in a UTF-8 environment, it will decode and it will check the character string matches. And so if you grep in that environment and then do the same grep for ASCII, having set lc_all equals C, it's a lot faster because it doesn't have to decode every single line.
Is there any reason grep needs to decode? Because if
Yes, it does. Okay, does grep even need to decode? Yes, it does. Because, well, I'm not sure how grep does it, but it should. And we're going to get to that question, but I'll give you a very brief answer, which is that you might have stuff in the file that is not encoded to the same bytes, but is the same string. Wah, wah, wah. Yes?
When you use UTF-8 fragment, does it use UTF-8 correctly, or does it use Perl's UTF-8 without?
Well, okay, so that's a great question. The question is, if you say use UTF-8 to tell Perl that your file is encoded in UTF-8, is it using the right or the wrong decoder? And I'm 95% certain. The answer is it's the wrong decoder, but that decoder is it is fine. It's safe for this. Given valid UTF-8, it will do the right thing. That is a good question, and I will have to mock up an unsafe or invalid input file, which is going to take a little work. But if you remind me later, I'll try and do it. Yes.
You talked about the wide flag.
Yes.
Also known correctly as the UTF-8 flag. Now, my experience is that for built-ins such as length to function correctly on text, they look at that flag. So if you, for example, you had an example of the Chinese character.
Yeah.
When they were decoded as UTF-8, because they use UTF-8 pragma, and that resulting string had the white flag on, which is what allowed the length function
Right.
to recognize that those were.
Yeah. Okay.
Go ahead.
Is the question then just what's up with that? Which is fine. I just want to make sure there wasn't a question I was cutting off.
My question is, doesn't that mean that you can use that white flag to decide if the string is supposed to be, is semantic to the string?
No. So the question is, are you sure you weren't wrong about the UTF-8 flag being a good indicator? God, I wish. No. So here's a great example. There was so this is the Unicode bug where people use this flag and it's wrong. There was code in NetSMTP that would say if the wide flag is turned on, then it means I need to encode things. But you can, through many totally valid means, end up with a string that contains a sequence of code points which are in fact UTF-8 octets that need to be sent over the wire just like that, but has the wide flag on. So, and that's not like somebody made a mistake, that's totally valid. The wide flag is only useful for the internal stuff. So length uses the wide flag to know how to look at the SVU-PV because it's written in C, but your code is not going to look at the C code. It's only looking at the contents of the Perl string. Now this is all assuming you're running on Perl 5.12 or later. If you're on earlier than Perl 5.12, the Unicode bug is a much more pernicious beast. I'm not going to cover it because that Perl is really, really, really old, and I don't want to talk about it. Yes, Todd, and then I'm going to keep moving, I think.
Yeah, I've slept since I've looked at this, but what if the string doesn't begin at the beginning of the PV? Meaning, if like you truncate the beginning of the string, doesn't that?
So so what, can you screw up the encoding? Is that the question? If the string doesn't begin at the beginning of the PV, so like if the head has moved over, that's not going to lead you to problems because the places where you can substring out of a string, those are dealing with the elements of the string in Perl space, which means the characters, the things that you can't through subster, for example, cut between several parts of the SVU-PV that form one character in the Perl space. Unless you use bytes, and then you get what you deserve. Okay, I'm going to keep going, but I'll answer anything at the end. It's David.
You might want to mention that the unsafe UTF-8 discipline just like flips the flag on regardless of what.
Yes, yeah. That's so. The reason that it's so much faster to use UTF-8 and not encoding UTF-8 is it reads a hunk from the file, puts it in SVU-PV, and turns on the wide flag. Done. And then the encoding and decoding bits by the bad codec are done when you read from the string or do these other things. It's not looking at the contents at all. So, yeah, there you go. All right. So, right, in the end, the last section wasn't so bad. We just say decode everything when you get it, document what your subs expect, encode it before you output it, and then you're done, right? Then you can go back to writing your program just like you were when you were only writing ASCII, right? You're done. We're finished. This has solved all of our Unicode problems. There's a quote on Stack Exchange from Tom Christensen who says, Unicode is fundamentally more complex than the model you want to impose on it. There's complexity that you can never sweep under the carpet. If you try, you're either going to break your code or someone else's. And at some point, you have to break down and learn what Unicode is about. And you can't pretend it's something that it's not. And that's the thing I'm going to talk about next. It's like talking about things like this, right? What is in that string? It's this. We have two characters, Latin small letter n, and combining tilde. What's the length of that string? 1. 2. Of course, right? Because a string, if it's a character string, is a string of characters. There's 2 characters there. Remember the beginning? We had bytes, characters, and what was the other thing? Grapheme clusters. This is 2 characters that form one grapheme cluster. God damn it. All right, so why does this matter? Does it matter? Of course it matters. What if you did this? What does this mean? Like, what are we padding to? Is it 4 characters? Is it 4? What is it? I will show you what is it is. Here's a program with some great bands. Okay? You're all practically experts by now. So what bugs have I already got? This is my whole program. What bugs do I have? Use UTF-8. Great. Anything else? I've got to put encoding on my standard out. Come on, stick with me, people. So we now know the contents of the elements of @names are character strings. And we can print them to the standard out, and we're going to printf them. I counted up Queensryche. It's clearly the longest string on my screen. That's 12. So I run this program, and I get this. So what's going on, right? Well, this is the boundary they should have all fit into. Can you see those purple lines? Okay. They should have all fit in there, and they're not. Well, here's what's going on. Husker Du is fine. Queensryche is fine half the time. That's because the first time I'm using character 255, my favorite character, Latin small letter y with combining diaresis. And in the second one, I've got a y and a combining diaresis character. So in one of these, it is 12 characters, and the other one, it's 13 characters. It's 12 grapheme clusters, but that doesn't matter. How about this next one? So this guy's name, great Japanese guitarist, that's only 5 characters. We already know that. It's not a whole bunch of crazy characters combining into grapheme clusters, but Japanese characters are just wide. That's how it goes. When you display them, they are twice as wide as other characters. So you need to say, I'm dealing with grapheme clusters. And then down here, you don't even say, tell me how many grapheme clusters. You say, how many columns will this string of grapheme clusters take up? And this will look at the character database and say, how wide is this character? This is not even about like font proportionality. Like in my terminal, this thing could be displayed in monospace width, but it would get 2 characters worth of width because that's how it's defined. And you run this program, what do you get? 9 for the first one, 11 for the next one, and then 11 again. This is good. It knows those 2 versions of the one grapheme cluster are the same. And then this guy's name, what are we going to get? 5 was one answer. Wait, what's the error?
You don't have 5.10.
I don't have 5.10. Well done, but no. It's a bug in my slide. Anybody else? 9, okay. Yes, 9, okay. Each Japanese character is double width. There's 4 of them, so that's 8 columns, plus the 1 space is 9. Grapheme clusters, they're great. Here's another example. Here we're matching a name. Your name is allowed to be 10 dots. What is a dot? A dot is a character.
So is it because they're like physically wider on the screen?
That's because they're physically wider on the screen, yep.
Right.
Okay.
As opposed to like wide characters.
And, oh yeah, great. Yeah, so that's about their width on the screen, their column numbers, and not because they are wide characters in the Unicode sense. Yeah, because you can have a very narrow character that's some high code point. Yes.
So on the previous slide, they looked like they were 1.5. Is that just because Keynote?
It's because, yeah, so I had to use quite a few different fonts in this talk to get characters that would look correct consistently. But yes, you're right. It's this particular font does not monospace properly. I found one that would have looked correct, but it was really, really ugly. So I stuck with this. And so that's on me. So dots, yes. Is there a reason I didn't use the double width space? It was because I was lazy, but I'm going to use the better answer, which is I was trying to trick you. It was because I was lazy, but the next time I give this talk, it'll be because I'm trying to trick someone. Okay. So the dot matches a character. And we don't want to match characters because, for example, if you match one character out of a string, which would have been a better slide, you could be pulling out just the N and dropping the tilde. And now what happened? There are stories in the news that I won't get into about people going over and assaulting other people because Unicode handling broke the diacritical marks on text messages they sent. Like, this is not a joke. You need to use \X. That will match a whole grapheme cluster at once. And here it will match 10 of them. Similarly, split, another place. Which Perl version of, 5.6, I think. So Unicode support started in 5.6, really. And I believe \Big X goes back to, Abigail, do you know?
It changes by \.
\Big X?
I think \X either 5.6 or 5.8.
Okay, so it's definitely 5.8 at the latest it became available. And as we have already established, no one in this building or state is running 5.6. Okay. So split's another way we interact with strings and regular expressions. But they're not about matching what's in the string. They're about what's not in the string sometimes. So this, especially this split. Split // is going to match between the characters. And so we get this. Split it up into a sequence of characters. But it's a sequence of characters, which means sometimes we get that. And we don't want that. We want to split it into the units of the string. And if the string is made up of grapheme clusters, we use this. \b is a boundary between stuff. There's different kinds of boundaries. GCB is grapheme cluster boundary. So here, split will split between each grapheme cluster. This became available in 520, I think. 520 or 522, it's quite recent. But I'm sure everyone here is running at least 522. That's just the right thing to do. So this is how you actually split up a string of grapheme clusters, which all text strings are. You don't have text strings that can be arbitrary Unicode that are not strings of grapheme clusters. They are. 22. 522 for B, GCB. Here we've got two different strings. They're the versions of the string we've been working with. One of them is 11 characters, one of them is 12, because one has Y with dots and one is Y and then dots. Are these strings considered equal by the equal operator? No, because it's comparing character strings. But they could be the same character string. Y with dots and Y dots, they're the same concept, and you can map them into the same concept. And one of the ways we do this is by normalizing the string. Look at the string and see what things could be mapped losslessly into a different string. So we use Unicode normalize. We normalize the string into NFC. The C means combining. It takes all the characters, and if it can combine them into a smaller list of characters, it does that, and these become equal. So does this solve our Unicode comparisons problem? Well, if we want to compare case insensitively, the standard programmer behavior since 1963 is to lowercase your input, right? And if you get the same string with two different casings, you lowercase it, they lowercase to the same thing, and your comparison works, which is great if you're like living in LA in 1982, but if you're living anywhere else, you're going to start hitting problems. So here we have Passstraße, and we lowercase that, and we get these two strings. They're not the same, even though it's the same word. So the solution to this problem is actually pretty simple. You just stop lowercasing everything and uppercase everything, right? Problem solved. Well, we might have these two strings. These two strings are Theotokos. We uppercase those, and we get these two things. What? So we can't uppercase the right way either. They look the same, but they're not. So what we end up using is something called fold case. This will take strings and map them into a case that exists for comparisons. It's not the uppercase, it's not the lowercase. Who knows the third case? Sorry? Fold case, okay, but there's who knows the fourth case? Title case, right. So naturally in Unicode, strings have lowercase, uppercase, and title case. And fold case exists for doing comparisons. So we fold case our strings. Now we're sorted. We take our strings, we fold case them, we compare them, and it works, right? Then we get to this thing. So we have these two strings. We fold case, this should be fold case, by the way. This is a bug in the slide. We fold case them, and they're not the same. I will tell you, though, these are the same thing. They're not the same character, but they're the same concept. What the hell is going on? The first one is X with combining horn and combining dot below. Okay, the horn is that little cross on the top right of the X. The second one is X with combining dot below and then combining horn. So we've got two diacritical marks, but they're in different orders. Fold case is not going to fold those to one thing. So what do? You use Unicode collate, and you tell it you want a collator. Collator is the annoying DBA word for sort. And you say, I want to compare these two strings. It's just like the CMP operator in Perl, so it returns -1, 0, or 1. So I'm asserting to you these two strings are, to use the jargon, canonically equivalent. So what is this going to return? 0. They are equal. Good, it works.
Case?
What about case?
That doesn't count for case.
This does not account for case. So you could take these, fold case them, and then compare for canonical equivalence, and you might be all right. Yes?
Would normalization handle this?
Normalization would not handle this. What a wonderful question, Len. Let's imagine that we had n, right? And this one, we have n with combining diaresis and combining tilde. Same problem, right? It's a letter and 2 diacritical marks. And then we have n and the 2 diacritical marks in a different order. Same as before, right? Do we agree this is the same thing? When I run this program, we get -1. Why are they not the same? Okay, we have an n. Let's go back and look. N diaresis tilde, right? N diaresis tilde or n tilde diaresis. So we have an n, we add a diaresis and a tilde, or we have an n, we add a tilde and then a diaresis. That's what they mean. With these guys, it doesn't matter the order you put them on in, because one's on the top and one's on the bottom. So those are equivalent, the other ones aren't. Isn't that clever? But you don't want to have to think about being that clever. That's why you use the library. Now, could you normalize these? That was the question. Can you normalize these two to be the same? And you can't. They will not normalize into the same ordering. It is possible that these 2 strings do. I haven't checked. But the general answer is no. If you want to compare 2 strings for sorting or equivalence, you have to use Unicode collate. Now, Unicode collate. Okay, so it's great. I will say, this doesn't mean you need to go to every CMP in your whole program and replace them. It does mean you need to think about the domain of values for your variables. Just like you had to say, is this text or is it bytes? You should think, is this ASCII text? Can I just use CMP? Am I only sorting this to make sure that it is in some order and I don't care what the order is at all? Because if that's the case, you could just use CMP or sort, and you'll get some kind of repeatable order. But it's not going to be semantically correct for text. Okay. While I was doing this and looking for these Greek examples, I found this character. Greek small letter omega with Dacia and perispomeni and still can't say this. Ipoegrammeni. Ipoegrammeni. Okay. This thing is a great character. Anybody know what that last yellow word means? I didn't until someone told me, oh, well, you have to pretend there's an H in front of it because it's Greek. Hypogrammeni. Gramme meaning to write, and hypo meaning under. That little dot under the W, omega, is the letter iota, which you can write as if it was a diacritical on lowercase letters. When you uppercase it, you get that. There's no lesson here, it's just neat. The other thing is I found this character and I thought, man, that's a heck of a name. Could this be the longest name in Unicode? Yeah, right, of course it wasn't, but I had to find out. So I wrote a little program and I found this thing. Arabic ligature Uyghur Kyrgyz, with Hamza above and Aleph Maksura, isolated form. This is the longest named character in Unicode. And it looks just like this other character. Do you see the difference in their names? One is Uyghur Kyrgyz, the other is not. Okay, so the one on the left is used when you write a particular dialect of Arabic. It's its own script, or its own combining version of a script. The other one is from a different version. And you look at these 2 characters, if you saw these printed, you'd never know that they were different characters. And this comes up a lot, even outside of Arabic. If I saw any Arabic characters printed, I wouldn't know they weren't any other Arabic characters. But how about these? All right, these 2 strings look just the same. And isn't this, it's okay, we already solved this problem, right? With n tilde and n plus tilde? No. Because those 2 strings are not equivalent. They're not the same string written in 2 ways. They're 2 totally different strings that visually look the same. So if you don't know what the hell is going on, maybe you will have seen this before. Getting email from these guys. The first one is PAYPAL, PayPal. The second one is PAYPA, Cyrillic letter Aleph, L. They look just the same, but one character is visually confusable with another. Or these 2 strings. First string is written in American. Second string is entirely written in Cyrillic. So these are visually confusable, and as you can imagine from PayPal, these are security problems, right? You can say, well, I'm not going to let anyone say that they're sending mail from PayPal. That would be crazy. But they can say it from PayPal.
Well, maybe we just need Cyrillic Latin unification.
Right, yeah, we should unify those. So these are in different scripts. Unicode knows about scripts. So our letter O is a Latin character. /P matches Unicode properties. And this has the property Latin. Properties aren't just flags, they can also be values. So SCX means its extended script name. And they're all 4 characters because they go to some ISO standard 10,000 something. So it is script equals Latin. You can assert matching strings that characters at given positions have these properties. Cyrillic has its own script. So one thing you can do is assert that your strings are in the script you expect. Is a question?
Does WAC-P match a character or
Yes.
does it match condition?
/P matches the character at the current position. You can intersect them. I'm not going to show that, but yes, you can do that with regular expression character set unions. They're in the documentation. Ask me later. So you can assert everything is in the same script, but even within one script, there are sometimes confusables. In fact, I'll go back to this thing. Both of these character strings are entirely in the Latin script. So you have to use a totally separate mechanism for detecting confusables, which is not part of normalization or fold casing or collation. I don't think we have a Perl implementation of the confusability algorithms. I could be wrong. I've never tried looking for them because it's too scary. Okay. This thing, who remembers that character? It was on the title slide. Yeah, right. So I'm going to load up the Unicode character database. That's where properties are defined and stored. And I'm going to say, what's the value for that string's numeric value? It's 1,000. So we can take our title slide, load all the boilerplate we've talked about this whole time. And was it 10,000 that you said?
No.
Okay. Take our string, that's our title of our talk, split it into characters. There's no grapheme clusters in this string, except, well, they're all single character grapheme clusters. We can split it into characters, get the ordinal value, that's the code point, get the code point number for each character, find out its numeric value, turn them into big floats, reduce them over multiplication, print it out, and we can end up with 1E15, or also known as a million billion. All kinds of really interesting information you can mine out about your strings by inspecting their properties. You can write, and presumably Perl 6 has written, the ability to have string literals written in any decimal character set, but don't match them because that becomes confusable. For example, I think it's Malaysian, like their number 4 looks exactly like our number 7. Pretty great. Okay, last thing I'm going to talk about is documents. Everything I've been talking about this last act of the talk is all documented in the Unicode standards. I will say that I love reading standards, and some people do not, but these are ones you really want to have a look at. Security considerations. This is all talking about those confusable characters I talked about. Technical report 36. The Unicode character database. You find out what the scripts of characters are, what their properties are, how to match them around. The collation algorithm. How do you compare strings for equivalence or for sorting? Really interesting. I mean, the other thing I love about Unicode is it's so culturally interesting. It talks about differences in how different countries sort their phone books. Amazing. Text segmentation. This is split. How do you split stuff? Unicode tells you how to split stuff not just by character, but by grapheme cluster, by sentence, by paragraph, and this is now implemented in Perl. Regular expressions, how they even should work. Identifiers and pattern syntax. Someone, I think it was you, Todd, someone said, why don't we have $smiley face yet? And it's because Unicode Technical Report 31 says these are the characters that are appropriate for variable names in programming languages. And we said, I'm glad you've done the work for us, right? we'll just go with that. And of course, the technical report everyone is most interested in is emoji, the driving force behind modern Unicode adoption. So you really do need to look at these and think about them in your program unless you are only working with binary data. And keep in mind that Unicode is fundamentally complex. There will never be libraries that abstract this much more than it already has been done, because the concepts themselves are irreducibly complex in many cases. Not all cases, but many. And if you think you can reduce it more, you should read the standards and publish the library, and I will use it and put it in the talk next year. Okay, so now you're probably feeling like this. That is actually, we're at the end. I only ran 30 minutes over. All right. Thank you, and thank you for being so patient with me. I do appreciate it, and I feel like this was important, and I'm glad I went this long. Do we have any questions? Yes?
The different forms of compatibility, and I know there's NFC and NFC.
Yes.
Are those related to the confusability stuff you mentioned?
No, so the question is, are normal forms like NFC, NFD, NFKC, are those related to confusability? I don't think so, no. There may be some relation in the sense that they try to, if possible, normalize things out of confusability, but confusability is about things that are, here's what I'll say. Normalization takes two strings that are canonically equivalent already and converts them into one string that is the same in both cases when possible. So normalization takes a string and turns it into something equivalent. Confusables are about two strings that are not equivalent, but visually, to the eye, appear the same.
So it's semantically distinct, visually equivalent.
Yes, that's a confusable, correct.
Is there a standard for identifying confusable strings and creating maybe a visual normal form?
I don't think there could be, because you can't normalize. So if you had PayPal and PayPal and you pretend that they're not a scam, right? They're two distinct things. I guess what you could say is, maybe what you mean is, can you convert them both to a form so you can identify them both as confusable with each other? Sorry? Render them to an image and do it, yeah. That doesn't reflect, I was going to point out earlier, you could see very subtle difference in the characters on some of those things. Because I really did use Cyrillic in one bit, and like the P has a slightly different stroke from the row.
It also depends on the font.
It depends on the font. The technical report on security considerations, I think it was 39, discusses the algorithm for normalizing this. So you probably could turn that into something visual. I would just turn it into a hash, or something like that. So that's the TR covers all of this, and it's actually really interesting because there are confusables that are only confusable because you mix in a character from another script, or confusables that are all in a single script, but they're confusable with each other, like the SOS, or ones where you have two strings, each all in one script, but they're different scripts and they're visually confusable with one another. So these very interesting different categories of it. David?
Are there any libraries or any sort of easy way within the regular expression to detect if a string is all of the same script? Regardless of what it is, like not just like, is this all Latin, is this all Latin, but like whatever it is, I want it to be all the same and not interleaving Latin and Cyrillic and other.
Yeah, so the question is, can you tell that a string, is there an easy way to tell that a string is all one script and not mixed? So, three answers to this. First one, I don't think so. Second one, it's actually pretty easy to write. It's, I'll say one line of Perl, but it's an annoying line of Perl that I wouldn't want to rewrite. Third thing is, like I said, this is a beta version of this talk, and there's two things that came out of this talk. The one is this talk should probably be like 6 hours long. The other is, there are a number of places where there is a possibility to reduce the complexity of things and have some helpers like that, and that is definitely one of the ones we want. Two things. One, to say, is this single script? Another, to say, are these strings confusable? And like I said, I don't think there's a confusability library on CPAN. There is.
Unicode colon
Unicode : security. It does exist. I haven't looked at it. I added the confusability stuff very late in the game. I haven't looked at it, but you should look at it, and I'll find out for next time.
The case where FC didn't work and you had to break out and use a module, is that, your answer might be it's the spec, but wouldn't you just fix FC to behave that way?
I'm trying to think of good examples where FC is not sufficient that I can explain. I'll try and think of an example. I know that I feel fairly certain that there are cases. Here's my short answer, and I think this is correct, but I haven't reviewed it, so if I'm wrong, I apologize. FC operates on characters, right? It iterates over a string of characters, and it changes each character into the fold case variant for it, or variants for that character. There are cases where the mapping is related on several characters in a row, and fold case won't do that. Fold case doesn't operate on hunks. It operates on individual characters. And the Unicode collation algorithm, which is incredibly complicated and powerful, will operate on hunks. For example, you got me into another crazy example. In the French phone book, if you are sorting two strings that are equivalent in the underlying letters but have different diacriticals, first you sort all those strings together. Then you sort them based on diacriticals, starting from the right-hand side of the string, not the left. I don't get it. I don't get it. I don't get it. Okay. Any other questions? Yes.
The UTF-8 flag is no good. Is there any thoughts about making something that would?
Yes. So the question is, can't you guys fix this garbage? Can we have a way to say that a string is text or is bytes? There are occasional rallying cries to get this done. I cried this out several times. It would be fantastic. It'd be really good. Perl 6, by the way, the solutions to these problems in Perl 6 are really, really good. And if you're interested at all, just go read about NFG, which is the normalization form they've invented for Perl 6. Fantastic. In Perl 5, we've talked about a number of ways to implement it. They all have a bunch of problems. I still hope it gets done, but it is a ton of work that will produce a bunch of backwards compatibility questions. So I hope something happens, but I am not hopeful. Yes?
Going back to my earlier question, I did some research to figure out what it exactly was. Prolog 31923. Basically, if you enable threads and then set the encoding through any one of many mechanisms to any form of UTF-8, it will segfault. The fix went in October of 2015, so I'm not even sure if it's on it's Perl or not. But
If the fix went in October 2015, then it should be in there.
The latest Perl won't crash.
More evidence. So the question, the statement was, there was a bug in Perl that affected your ability to use threads and encoding in certain situations. It has been fixed. This is more evidence you should all be running Perl 5.24. Okay. Anything else? Oh yes, in the back.
What is your position on Han unification?
I'm not getting into that. What is my position on Han unification? I don't have one. I don't know anything. I know almost nothing about the linguistics questions involved, and that's the kind of thing where I hope the linguists make the right influence on the Unicode Consortium, but I'm out of it because I'm not an expert in any way on that question. Anybody else? All right. Thank you very much. I hope you can all still find lunch and keep it down.